Yesterday, the National Weather Service activated 26 red flag warnings simultaneously across 6 western states. One continuous fire weather corridor running from the Sierra Nevada to the Texas Panhandle, covering roughly a third of the contiguous United States. Humidity is forecast at 4% in the Panhandle, gusts to 70 on the Mojave Desert Slopes, fuels at the 90th percentile of dryness for the date. The fire season is not supposed to start for another 3 to 6 weeks. By the end of this video, you'll understand exactly what's on the field and what happens next. Yesterday, the National Weather Service activated 26 red flag warnings simultaneously across 6 western states. They form one continuous corridor running from the southern Sierra Nevada in California, down through the entire Mojave Desert, across the Four Corners region, through northern Arizona and most of New Mexico, and terminating in the Texas and Oklahoma Panhandle. 8 fire weather watches extend that regime through Monday. The corridor spans roughly a third of the contiguous United States in a single afternoon. This is the structural part you need to understand. The western fire weather season climatologically opens in mid to late June across most of the affected geography. It peaks in July and August. May 16th is 3 to 6 weeks ahead of historical onset. The operational conditions on the map today are not what mid-May normally looks like. They are what peak July normally looks like. The numbers under each warning are not a regional fluctuation. They are the upper edge of what the operational fire weather community flags without going to the highest tier on the rating system. The Storm Prediction Center confirmed that yesterday afternoon by issuing a Day 1 fire weather outlook with 3 risk categories live at the same time: elevated wind and humidity, critical wind and humidity, isolated dry thunderstorm. That combination, on a single afternoon, across the geographic footprint that's affected, is the maximum operational designation short of declaring an extreme day. Any day this regime stays open is a day with the natural ignition source, lightning, in the forecast over fuel that has nothing left to give, and the regime stays open through Monday. The hardest hit zone right now is the Texas and Oklahoma Panhandle. Under a red flag warning, the National Weather Service Amarillo office issued at 8:18 in the morning Central Time. The forecast calls for relative humidity to fall as low as 4%. 4%. That is 1/4 of the standard 15% threshold that triggers red flag warnings across most of the western United States. Temperatures will reach the mid-90s to the low 100s. Winds today come out of the south-southwest at 10 to 25 miles per hour, gusting to 30. Tomorrow they escalate to southwest at 20 to 35, gusting to 45. And the fuel underneath those numbers is sitting at the 90th percentile of the historical energy release component for May 16th in this region. Of all the May 16ths in the modern record for the Panhandle, only 10% had fuel as dry as today's. The vegetation is not curing, it is cured. It is operationally indistinguishable from peak summer fuel. This is the same county footprint that produced the Smokehouse Creek fire in February of 2024. That fire burned approximately 1,074,000 acres, with 500,000 of those acres consumed in the first 12 hours under sustained 60-mile-per-hour wind. The conditions on the field today in this geography either match or exceed the conditions that produced the second largest wildfire in United States history. A few hundred miles to the west, the National Weather Service Hanford office in California issued a separate red flag warning at 3:57 Pacific time. It covers the Indian Wells Valley and the Kern County Desert, which sit at the eastern edge of the Mojave. Inside the Mojave proper, the forecast calls for west winds of 20 to 30 miles per hour with gusts to 45. But on the Mojave Desert Slopes, where the terrain accelerates the downslope flow, the forecast escalates dramatically. West winds of 35 to 45 miles per hour, gusts up to 70 miles per hour, relative humidity in the 10 to 20% range at minimum. The same office issued a companion high wind warning for the Mojave Desert Slopes, and the language inside that warning is one of the bluntest pieces of operational text the National Weather Service produces. Damaging winds will blow down trees and power lines. Widespread power outages are expected. Travel will be difficult, especially for high-profile vehicles. Now think about what those words mean when you place them on top of a fuel bed at the 90th percentile of historical dryness, with humidity in the low teens, in a region where every power line within the warning footprint is being shaken in winds approaching its structural rating. Damaged power lines are one of the leading single causes of California wildfire ignition. The campfire that destroyed Paradise, California in November of 2018 and killed 85 people was ignited by a failing electrical transmission line under exactly this combination of wind, humidity, and fuel. The wind state today on the Mojave slopes exceeds the wind state that produced the campfire. To the north, The National Weather Service Sacramento office issued a red flag warning at 2:11 Pacific Time covering south central Shasta County, including the Redding metropolitan area, plus the northern Sacramento Valley into Tahoma County, central and eastern Glenn County, and Butte County below 1,000 feet. North winds of 20 to 30 miles per hour, gusts of 35 to 45 miles per hour, locally up to 50 miles per hour around the Delta and the western Sacramento Valley. Daytime minimum humidity is forecast at 7 to 15%. The forecasters add one more line that quietly tells you what they're worried about. Overnight maximum humidity is only 20 to 50%. That range is too low to refresh the fuel bed before the next afternoon's heating cycle starts the dry down again. The fuel does not get a recovery window. Every afternoon for the next 3 days, the fuel matrix wakes up drier than it was the morning before. The Redding metropolitan area sits inside this corridor. Redding is the same city that, in July of 2018, lost just over 100,000 acres of surrounding land and 7 lives to the Carr fire, a fire whose most documented behavior was the development of a fire whirl over the Whiskeytown area. That whirl, in post-event analysis, was rated at the equivalent of an EF3 tornado. It uprooted oak trees a meter in diameter. It threw vehicles. It stripped asphalt off the road in patches. It killed a Redding firefighter sheltering in a fire engine the whirl picked up and destroyed. The forecast for the Sacramento Valley today has the same wind, the same humidity, and a fuel state that is drier today than it was on the day the Carr fire ignited. The Storm Prediction Center's Day 1 fire. Weather Outlook is the operational document the fire management agencies read first every morning. It organizes the country into categories that scale with severity. Elevated is the lowest tier. Conditions are conducive to enhanced fire behavior, but not necessarily to extreme behavior. Critical is the next tier. Wind and humidity have reached levels that historically produce significant fire growth. Isolated dry thunderstorm is a separate category that flags the natural lightning ignition risk. And then there's extreme, reserved for the absolute upper tail of the operational distribution, issued only a handful of times per year. Yesterday's outlook carried 3 of those 4 categories simultaneously across one continuous geographic footprint. Elevated, critical, and isolated dry thunderstorm all live at the same time. That combination is the maximum operational designation short of going to extreme. The fire weather meteorology community is essentially telling you, in the only way it has institutional permission to communicate it, that today is the upper edge of what they can flag without invoking the highest tier on the system. Why does this matter beyond the alphabet soup? Because the isolated dry thunderstorm overlay places a natural ignition source directly on top of the dry corridor. A dry thunderstorm is a storm that produces cloud-to-ground lightning, but whose precipitation evaporates before reaching the surface. The ignition mechanism arrives without the rain that would normally suppress it. The August complex fire of 2020 in Northern California, the single largest fire in California history at just over 1 million acres, had approximately 50% of its ignition cluster traced to one dry lightning outbreak between August 16th and August 17th of that year. The same kind of outbreak is currently in the forecast for today. Here is where the regime gets structurally unusual. The Storm Prediction Center's Day 1. Convective Outlook places an enhanced risk of severe thunderstorms across the central high plains for the same afternoon. The enhanced risk box explicitly calls for wind gusts of 75 miles per hour or higher, hail of 2 inches or larger, and a few tornadoes possible. The Day 2 outlook upgrades that severe corridor into central Nebraska and southwest Minnesota for Sunday, with supercells, very large hail, and tornadoes expected. That severe thunderstorm corridor sits immediately east of the easternmost red flag warning in the Texas and Oklahoma Panhandle. The 2 corridors are not on opposite sides of the continent. They are touching. The boundary between them is the operational dry line that separates moist Gulf of Mexico air to the east from dry continental air to the west. The dry line is the focus for the severe thunderstorm activity, and the dry line is also the focus for cloud-to-ground lightning. If a thunderstorm produces lightning that crosses the dry line westward into the red flag corridor, it lands on dry fuel under wind. Whether or not that crossover happens, and exactly where, is not something the forecast can specify in advance. It depends on the moment-to-moment evolution of individual storm cells through the afternoon, but the operational possibility is on the table over the next 72 hours. The natural ignition source for a megafire class event could deliver itself onto the dry corridor by tomorrow night, and the operational fire weather community knows it. That's why the pre-positioning of federal initial attack resources across the western United States has been happening for weeks. The reason this regime feels different is that we have a very specific reference class for what happens when conditions look like this. Every modern American megafire that has produced significant loss of life or significant loss of homes was ignited under conditions today's regime either matches or exceeds. The reference class is not theoretical. It is the empirical record of the past decade. The Camp Fire ignited on the morning of November 8, 2018, in the Sierra Nevada foothills above Paradise, California. East-northeast winds of 15 to 30 miles per hour, gusts in the high 50s and low 60s. Relative humidity 10 to 15%. The atmospheric column above the area was carrying a Diablo wind configuration, the Northern California version of the dry downslope offshore flow that periodically descends out of the Great Basin in autumn. The ignition came from a 100-year-old electrical transmission line whose structural margin had degraded to the point where, under wind loading, it failed. The conductor fell. The arc ignited the fuel. Within an hour, the fire had spotted miles ahead of its front through embercast. The mechanism in which a wildfire under high wind throws burning fragments downwind that produce secondary ignitions far ahead of the main flame. 85 people died. 18,804 structures were destroyed. The mechanism that destroyed Paradise was embercast under 60-mile-per-hour wind. Move backward 1 year. The Tubbs Fire ignited on October 8, 2017, in Sonoma County. The conditions were almost identical to what would follow a year later in Paradise. A Diablo wind event with gusts in the 50 to 70-mile-per-hour range, single-digit humidity, cured fuel in the chaparral and oak woodland of the wine country foothills. 22 people died. Approximately 5,600 structures were destroyed. Whole neighborhoods in the urban core of Santa Rosa burned, not because the wildland fire front reached them, but because embers carried miles on the wind landed on roofs. The Tubbs Fire is the modern proof of concept for urban conflagration driven by embercast. The wind state on the Mojave Desert Slopes today exceeds the wind state that drove Tubbs. The Marshall Fire ignited on December 30th, 2021 in Boulder County, Colorado. Peak wind gusts of 115 miles per hour at Arvada, 110 miles per hour at Rocky Flats. Relative humidity 20 to 25%, 1,084 homes destroyed, 2 fatalities. The Marshall Fire's operationally important detail is that no red flag warning had been issued. The humidity at the time of ignition was higher than the then active 15% threshold the Boulder office used for red flag issuance. The fire occurred under conditions that exceeded the operational warning threshold of the day. After the Marshall Fire, the National Weather Service Boulder office revised its threshold criteria to incorporate the wind state as a cofactor with humidity. That revision is why today's Mojave Desert Slopes warning, with gusts to 70 and humidity at 10 to 20%, was issuable under the new framework. The operational fire weather community has explicitly learned from the Marshall Fire and incorporated that learning into the warning system that produced today's corridor. The Smokehouse Creek Fire ignited on February 26, 2024, in the Texas Panhandle. Within 12 hours, it had consumed approximately 500,000 acres. By the time it was contained, it had burned through approximately 1,074,000 acres, becoming the second largest wildfire in United States history. Sustained 60-mile-per-hour wind. Single-digit humidity. The geography is the same county footprint currently under the most intense red flag warning in today's corridor. The Texas and Oklahoma Panhandle today is the exact ground the Smokehouse Creek Fire burned through. The wind, humidity, and fuel state numbers either match or exceed those Smokehouse Creek conditions. The Carr Fire Whirl, the August Complex Dry Lightning Ignition Cluster. The case studies all point in the same direction. Wind in the moderate to high range, single-digit to low teens humidity, a cured fuel matrix preconditioned by drought, an atmospheric column structured for plume-dominated growth, an ignition source that arrives faster than suppression can respond. That is the operational fingerprint of every modern megafire. That fingerprint, in every measurable dimension, is on the field across 6 western states today. The structural question, the one the operational fire weather meteorology community is actually asking out loud in its morning discussions, is why this regime is on the field on May 16th instead of late June or July. The answer is in the climate attribution literature. The single most important paper on the role of atmospheric thirst in modern wildfire is the 2019 Williams and Abatsoglu paper in Earth's Future, Observed Impacts of Anthropogenic Climate Change on Wildfire in California. It analyzed approximately 50 years of California fire records and decomposed the doubling of summertime burned area into the variables that mathematically explained it. The dominant single explanatory variable was the vapor pressure deficit trend. Vapor pressure deficit measures how aggressively the atmosphere pulls moisture out of any surface it touches, and it scales nonlinearly with temperature. Every additional 1 degree Celsius of warming raises the air's water-holding capacity by approximately 7% through the Clausius-Clapeyron relation. The paper concluded that approximately half of the doubling of California's summertime burned area between 1972 and 2018 was directly attributable to the vapor pressure deficit increase alone. The foundational attribution paper is the 2016 Abatsoglou and Williams paper in the Proceedings of the National Academy of Sciences, Impact of Anthropogenic Climate Change on Wildfire Across Western U.S. Forests. It concluded that approximately 55% of the observed increase in fuel aridity across western United States forests since 1979 is attributable to anthropogenic warming, and that climate change approximately doubled cumulative forest fire area between 1984 and 2015. The National Interagency Fire Center, the United States Forest Service, the Bureau of Land Management, and the Intergovernmental Panel on Climate Change all reference this paper when describing how wildfire risk in the western United States has measurably changed. The third paper is the 2015 Jolly paper in Nature Communications, which documented a global 19% increase in fire weather season length from 1979 to 2013, with North America averaging an approximately 4-week expansion of fire weather days. Today's corridors sitting inside that expanded season. The fact that peak July conditions are on the field on May 16th is the operational verification of what the climate attribution work has been predicting for approximately a decade. The drought baseline this regime is operating on top of is the worst on the modern United States observational record. 8 western states posted near record low snow water equivalent values on April 1st. The Palmer Drought Severity Index for March and April of this year is within 1/10 of 1 unit of the Dust Bowl peak of 1934. The 2022 Williams, Cook, and Smerdon paper in Nature Climate Change documented that the period 2000 to 2021 was the driest 22-year stretch in the southwestern United States in at least 1,200 years, with approximately 42% of the soil moisture deficit attributable to warming. Under that mega-drought baseline, a single dry month does not produce normal year fuel conditions. It produces fully cured fuel matrix months early. That's what today's corridor is operating on top of. There's one operational metric worth understanding because it tells you exactly how prepared the fuel is for ignition. It's called live fuel moisture content, and it tracks the water content of living vegetation as a percentage of dry weight. A reading above 100% indicates a seasonally healthy plant. 80 to 100% is normal seasonal drying. 60 to 80% is critical. The plant is shedding water faster than it can take it up. And below 60% is the ignition floor, where the plant is operationally indistinguishable from dead fuel and any spark under wind produces explosive fire behavior. California's Department of Forestry and Fire Protection samples chaparral across the state on regular schedules. The values being reported from Southern California chaparral by early May this year are in the high 70s and low 80s% range. That value is normally not reached until mid to late June. The fuel is curing approximately 6 weeks early. And 6 weeks happens to be exactly the temporal anomaly between today's corridor activation and the climatological start of fire season. What this means, in plain terms, is that the climate attribution work, the megadrought baseline, the snowpack collapse, the heat domes of the past 2 months, and the operational fuel moisture readings all converge on the same conclusion. The fire weather season has not just expanded into a window it did not historically occupy. The fuel itself has been pre-staged for that expansion. Today's corridor is what the science has been predicting since at least the Jolly paper of 2015. The paper said the fire weather season would expand. The Williams and Abatsoglou papers said vapor pressure deficit would drive that expansion. The Williams, Cook, and Smerdon paper said the southwestern megadrought baseline would amplify it. The conditions on the field today are the operational verification of all of it. The forecast through Monday keeps the corridor open. The Mojave Desert Slopes hold gusts in the high 60s and low 70s through Sunday night. The Texas Panhandle sees 4% humidity again on Sunday. The Sacramento Valley holds humidity in the single digits to low teens across the entire window, with overnight recovery values too low to refresh the fuel bed. The dry lightning risk remains in play for at least the next 48 hours. The prepositioning of federal initial attack resources is fully active. Every county under warning is in the operational state, where any ignition is expected to escape initial attack. The fire management agencies have known this corridor was coming since the warning forecast went out earlier in the week. Beyond Monday, the National Interagency Fire Center's Predictive Services Outlook projects above normal significant fire potential across most of the western United States for June, July, and August of this year. That outlook was published before this corridor activated, and it stands today. The fire season this country is heading into is not expected to be easier than the regime that's active right now. It is expected to be the multi-month version of the regime that's active right now. The conditions are not the events. A fire requires an ignition, and ignitions are not perfectly forecastable. But under the regime on the field today, every spark starts a fire. The ignition probability calculation that fire behavior models output, given today's humidity, temperature, fuel moisture, and wind, comes out to approximately 100% for a single dropped match on cured grass anywhere across the corridor. The historical record gives no examples of a corridor of this footprint, this duration, this temporal anomaly, and this drought baseline that did not produce at least one defining fire event within the immediate window. The forecast extends through Monday. The drought extends through the summer. We will be tracking this as it develops, and we will know within the next 48 to 72 hours where the corridor's first major ignition lands on the map.